Hi everyone, this is Dr. G. Ravindranath Reddy working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So we are discussing numerical methods and integral transform course. In that course, we are at the infinite Fourier sine and cosine transforms. So we are discussing the Fourier transform unit. In that unit, we are at the topic of infinite Fourier sine and cosine transform. So in this video, we are going to discuss infinite Fourier sine transform, standard formula for infinite Fourier sine transform, and how can we find out, how can we apply that formula to the problems, and infinite Fourier cosine transform. So standard formula to find out the infinite Fourier cosine transform for the given function, and we will take some problems on this topic. So these are the two topics we are going to discuss: infinite Fourier sine and cosine transforms. So first we will take the infinite Fourier sine transform. So this is the standard formula to find out the infinite Fourier sine transform of f of x, and is given by, so infinite Fourier sine transform, it is represented with f suffix s. So f suffix s represents the Fourier sine transform of that function f of x. So whose infinite Fourier sine transform value is represented with f suffix s of p. Now if you solve this integral 0 to infinity f of x into sine px dx, you will get a value in terms of p. So we will consider that value as f suffix s of p, which is Fourier sine transform of f of x, which is infinite. And now whenever we want to prove any deductions or any conditions by using this infinite Fourier sine transform, we will use this inverse Fourier sine transform of the function. So whenever he has given the value f of p, f suffix s of p, and ask to find out that function which is related to this f suffix s of p. So in this case, then we can use the concept of inverse Fourier sine transform of the function. And similarly, we will go for the infinite Fourier cosine transform, whose formula is so infinite Fourier cosine transform, which is represented with f suffix c of that function for which we are going to find out that infinite Fourier cosine transform, and is represented as f suffix c of p, which is given by this integral 0 to infinity f of x cos px dx. And whenever this f suffix c of p value has given, infinite Fourier cosine transform of function is given, and asked to find out its corresponding function f of x, then we can use the concept of inverse Fourier cosine transform. So by using this formula, we are going to find out the value of f of x whenever its Fourier cosine transform value is given in the problem. So these are the standard formulas we are using to find out infinite Fourier sine and cosine transforms and its inverse. Now we will take some problems on this. Now let us take the problem. So find the Fourier cosine transform of e power minus ax into cos ax. So here we are having two types of Fourier sine and cosine transforms. One is infinite and the next one is a finite, which we will discuss in the next video. So now in this problem he has not mentioned either infinite or finite. So now which formula we have to use now? Either we have to go for the infinite or we have to go for the finite. This is the confusion we get. So whenever they ask to find out Fourier cosine transform of some function and the interval is not given in the problem, then by default we have to go for the infinite Fourier transform here. Suppose if the given condition is like this, if the given condition is in terms of infinity, like this 0 less than x less than infinity, so here we are having the infinity, so we can go for infinite Fourier transform. Either that will be mentioned, either sine or cosine, that will be mentioned in the problem, so no need to worry about this. So in order to identify either we have to go for infinite or finite, then sometimes they will give the condition as 0 less than x less than infinity, so you will get the condition in terms of infinity. So whenever we are having the range in terms of infinity, then we have to go for the infinite. At some for some problems they will not mention any condition. So in that case also by default we have to go for the infinite Fourier sine or cosine transform which is mentioned in the problem. So now here he has mentioned Fourier cosine transform. So now since we don't have any condition here, so by default we have to choose infinite Fourier cosine transform. Cosine transform is mentioned in the problem, so we have to consider that part. Now we have seen the standard formula for infinite Fourier cosine transform. Use that formula. So whatever the function he has given, you consider that function as f of x. For this function, you are going to find out infinite Fourier cosine transform. Now we will see how to find out this. So this is the function he has given, f of x is equal to e power ax into cos ax. Now take the standard formula. So infinite Fourier cosine transform. So f suffix c of f of x, that is the representation of Fourier cosine transform, and the limits are integral 0 to infinity f of x into cos px dx. Now you replace that f of x value in this integration, in this function, in place of f of x, and if you evaluate that integration, then what you will get that value which is in terms of p. We will consider that value as a Fourier cosine transform infinite. So now substitute that f of x is equal to e power ax into cos ax, and replace this, and e power ax into, once if you observe this cos ax into cos px, this is of the form 2 cos a cos b. So here I want to multiply the numerator and denominator with the 2. So whatever the denominator we are having, I have taken the denominator outside, and in the numerator I have considered that 2 with cos px and cos ax. Now apply 2 cos a cos b formula. So this is the formula here, cos of a plus b plus cos of a minus b. So here px and ax. So from these two terms I have taken x common in both terms here. So you will get cos of p plus a into x plus cos of p minus a into x. Now separately you apply the integration by multiplying with e power ax. So integral of e power ax into first term plus integral of e power ax into second term. So separately apply this integration here. So this 1 by 2 is common for both terms. So 1 by 2 integral 0 to infinity e power a minus ax into cos of p plus ax, plus multiply with the second term integral 0 to infinity e power minus ax into cos of p minus a into x dx. Now we have the formula integral 0 to infinity e power minus ax into cos px. Use that formula here. So this is the formula you are having, integral 0 to infinity e power minus ax into cos bx. So directly without using that standard formula, whenever we are having the limits 0 to infinity, directly we can take that integral value is equal to a by a square plus b square. Now substitute this. So a by a square plus p plus a whole square, this is the, so in place of a take a is equal to a only here. In place of b, here you will get, for the first term you will get p plus a, for the second term you will get that p minus a, second integral. Now substitute this and simplify. So by taking the LCM here, so finally you will get this value here. So Fourier cosine transform of f of x is equal to, after simplification here, finally you will get this value, a of 2a square plus p square by a square plus p plus a whole square into this one. So this is our required Fourier cosine transform of f of x here. So this is the way how we can use. Now just remember this formula here. So once if you remember this formula, so we are having another formula, integral 0 to infinity e power minus ax into sine bx dx. So this can be written as b by a square plus b square. So here we are having cos, so you take a by a square plus b square. So whenever we're having in place of cos, if we get sine bx, then we can take the denominator is same in both formulas. So just numerator will be changed. That is b by a square plus b square. So these formulas are very important in the Fourier transforms. Like we can save our time if you remember these formulas here. Now we'll go for the second problem. So show that the Fourier sine transform of, he has given some f of x value. F of x is equal to x whenever that x lies between 0 to 1, and he has given one more value for f of x, that is 2 minus x whenever that x lies between 1 and 2, and finally he has given f of x is equal to 0 whenever that x value is greater than 2. So for this function, if you find out that Fourier series here, then that Fourier sine transform of this function, this is equal to this 2 sine p of 1 minus cos p by p square. This is the value we have to prove here. So now same case. So our x value starts with 0 in the first condition and ends with x greater than 2, means that x value it may be approached to infinity. So from this, once if we observe this interval here, our interval starts from 0 to infinity, x greater than 2. X value is more than 2. So we don't have the dating, so we can consider that as a infinity here. So here the limits are, here the interval he has mentioned as 0 to infinity. So whenever we are having the limits as 0 interval as 0 to infinity, then by default we have to choose infinite. And in the problem he has mentioned sine transform, so we have to use infinite Fourier sine transform value for this function. So this is the function he has given, and take the formula. By definition we're having, this is the standard formula for infinite Fourier sine transform. Now here in the previous problem we are having only a single value for f of x, so here we have substituted f of x value directly in the previous videos while you are finding the infinite Fourier cosine transform. But in this problem we are having multiple values for f of x here. Now what we have to do is, so this interval we have to divide into a sub intervals, that is one is 0 comma 1, and the next one is 1 comma 2, and the next one is 2 comma infinity. So these are the three sub intervals we have to consider this interval 0 comma infinity. So according to this we are going to divide this integral. So one is 0 to 1, so this is 1 0 to 1, and the second one is 1 to 2, and the third one is 2 to infinity. So now based on these limits, based on these intervals, now substitute the values of f of x. So whenever that x lies between 0 to 1, yes, when f of x is equal to x, so replace with this f of x value with x. Whenever x lies between 1 to 2, yes, when f of x is equal to 2 minus x, so in this replace f of x with 2 minus x. And whenever that x value is greater than 2, or whenever that x lies between 2 to infinity, then that f of x value has given as 0. Now replace in all these three integrals, replace the values of f of x based on the conditions here. So when we replace f of x is equal to 0, then this third integral will be vanished, so that will become 0. So we have to concentrate only on the first and second integral here. So after neglecting this, so these are the two integrals remains here. Now solve these two integrals here. X into sine px dx, apply integral of uv. Here also you apply the integral of uv formula. So after applying that integral of uv, you will get these values here, and substitute the limits in place of 4. So here we have applied the integration with respect to x. Dx means with respect to x. Now you substitute these limits in place of x here. So first substitute x is equal to 1, minus substitute the x is equal to 0, which is a lower limit in both terms. So here after substituting this, finally you will get this value. Put x is equal to 1 here. So minus 1 by p into cos p. So you will get this term. Now substitute x is equal to 1 here, 1 by p square into sine p. So this is the upper limit. After substituting the upper limit, x is equal to 1. Now substitute x is equal to 0 here. So in place of x, if you substitute x is equal to 0, 0 by anything equal to 0, 0 into anything equal to 0, the first term becomes 0. And now substitute in x is equal to 0 in the second term, so you will get sine 0. So if you substitute x is equal to 0, 0 into p is 0, sine 0 is 0, 0 by anything equal to 0. So after substituting the lower limit, both terms becomes 0, so we can neglect that value here and follow the same procedure here. Put x is equal to 2, upper limit, put x is equal to 1. So if you substitute x is equal to 2 in place of x, 2 minus 2, 0, 0 by anything equal to 0, 0 and anything equal to 0. So this after substituting x is equal to 0, x is equal to 2, the first term becomes 0. Now take the second, put x is equal to 2 here. So minus 1 by p square sine p into 2. So this can be written as sine p minus, substitute the lower limit. X is equal to 1, 2 minus 1, 1, minus of minus, you will get cos p by p. Here you will get 1 by p square into sine p. So this is our value. Now simplify this. After simplification, you will get these terms here. So this is our required. This is our required infinite Fourier sine transform of the given function. So simplify this according to our condition. This is our given condition. Okay, this is the value we have to prove. Now let us take one more important problem. So he has given some function, and for this we have to find out the Fourier sine and cosine transform here. So this is first we will find out the Fourier sine transform by taking the same formula which we have discussed in the previous video, and in place of f of x you substitute this value here. So now once after substituting this in this formula, we have the formula just now we have seen in the previous videos. So whenever the limits are 0 to infinity and sine bx, when sine is multiplied with exponential function, then directly we can use this formula here. Here b is, if you compare this, here you will get b is equal to p. So p by, so already 2 is there, so keep that 2 as it is. P by a, here a in place of a you replace the same here. In place of a, here we are having 5, so a square, that is 5 square 25 plus b square, b is p, so you will get this. And similarly follow the same formula for this second integral, so you will get 5p by p square plus 4. So this is our required Fourier sine transform of that f of x, infinite Fourier sine transform of f of x. And similarly for the same function we have to find out the Fourier cosine transform here. So follow the form, take the formula, replace that f of x values here. Now remove these brackets by multiplying with cos px with these two terms. So you will get integral 2 into integral 0 to infinity e power minus 5x cos px, and 5 into integral 0 to infinity e power minus 2x cos px dx. Use the formula. We have the shortcut formula in order to evaluate these integral values. So here you will get a is equal to 5 and b is equal to p. Now substitute in these two integrals a place. In this you substitute a is equal to minus a equal to 5. The first integral you will get 2 into 5, 10 by p square plus 25, and here you will get a is equal to 2, 5 into 2, 10, p square plus 2 square, that is 4. So this is the formula here. This is our standard value for Fourier cosine transform of the given function here. So now we have used only infinite Fourier sine and cosine transforms. Now we will take some problems on the inverse of these two, infinite Fourier cosine transform and infinite Fourier sine transform and its inverse. We will take that problem here. So find the inverse Fourier cosine transform of f of x. For this is the infinite Fourier cosine transform value has given. By using this we have to find out this f of x value here. That is the meaning of this. So whenever Fourier transform value is given, Now by using that Fourier transform, if we want to find out the function for which we got this Fourier cosine transform value, that is the meaning of this. So take the inverse formula Fourier cosine transform. So f of x is equal to 2 by pi integral 0 to infinity f suffix c of p into cos px dp. Now whatever the value he has given, he has given f suffix c of p is equal to with these values here. Now here two we are having two values for this Fourier cosine transform. Now according to these conditions, you divide this integral 0 to 2a, integral 0 to infinity into two subintervals. One is integral 0 to 2a and the next one is 2a to infinity. 2a to infinity. Now whenever that p value lies between 0 to 2a, this is the value he has given for that f suffix c of p. Substitute. And whenever that p lies between 2a to infinity, then its Fourier cosine transform is given as 0. You replace that 0. So the second integral becomes 0. 0 into anything equal to 0. Integral of 0 is 0. Now simplify this. So this 2 and this 2 gets cancelled. So you will get 1 by ap and integral a minus p by 2 into cos. Apply the integration with respect to p. So you consider this as u and consider this as v. Apply integral of uv formula. So then substitute the upper limit and lower limit here. So finally you will get f of x is equal to, this is the value of f of x for which we got that Fourier cosine transform value. So sine square ax by, so this 2 and this 2 gets cancelled, a pi x square. This is the value what we want. So this is the way how we can apply this inverse formulas to get the value of f of x here. So in this video we have discussed infinite Fourier sine and cosine transforms with the standard formulas and its inverse formulas with some examples here. Now in the next video we are going to discuss what is a finite Fourier sine and cosine transforms, how to find out the finite Fourier sine transform and finite Fourier cosine transform for the function f of x. Thank you.